now we talked about average rate of change in the last video. Now using the difference quotient as the average rate of change. The difference quotient, which again, typically in a good, especially in an advanced algebra class, they usually introduce difference quotient and have you practice simplifying it, which you're going to need to know how to do in this section and the next section. Alright, the difference quotient is just a way to rewrite, all we're doing is rewriting the average rate of change into an expression that will be easier to manipulate algebraically, and easier to deal with algebraically. Alright, so that's all it is. Alright, it was developed as an easier manipulation of the average rate of change, which we'll need because we're going to use it in the next section with limits. We're going to use it with limits, so it's much easier to use the difference quotient versus the original expression of the average rate of change. Alright, so remember, this is the original expression of the average rate of change, right? Change in my function, the y values, over the change in x. Again, that's still slope of my secant line. And then all we're going to do is we're going to rewrite it using different notation. So instead of 0.1, we're going to let it be a general x value. I can start at any x value on my function. And instead of 0.2, we're going to say, well, I can't be at my same x value, but I've got to be a little bit away from my x value. And so we make 0.2 x plus h, where h is not 0. And what h represents that change in x, going from 0.1. And so what h represents is it can be any distance from my starting point. All right, I can go 1 unit away, 2 units away, 3 units away, half a unit away, a quarter of a unit away. All right, whatever, it's change in x. And that's important because we're actually going to manipulate that change in x. All right, that's going to be an important tool to use and understand. And so that's what that h represents. It represents this in general terms, where I can pick any starting point on my function and any value distance away from that starting point, any change of x from that moment. All right, and so when we do that, so what we'll do, so again, we're just replacing x1 with x, so there I've replaced x1 with x, x2 with x plus h, change in x, and then we simplify. Right, up top has to stay the same, there's no simplifying there. F of x plus h, right, because I replaced x2 with x plus h, and then this is just f of x in general. In the bottom, though, we can simplify. This x can cancel with this x, and here we get the difference quotient. There is my difference quotient. So whenever we say difference quotient, what that means, it's f of x plus h, my function, where I plug in x and x plus h, minus my function f of x, all over h, which h represents a change in x. It is still the average rate of change with respect to, the key here is now it's with respect to any x value, any starting point. H can't be 0 because it represents a change in x, right? And plus I can't divide by 0. Right? And it represents a change, a distance change in x. It's still slope with a secant line. So when I graph it, I get the similar picture to what I had before. So I'm going to try to graph similar to what I had on the previous example. So I had a cubic function. Alright, so I could pick anywhere on this function. Anywhere I want. Alright, so again, suppose I pick this as my starting point. So that would represent any x value. That would be x, f of x. Any point on my curve I could have chosen. And then I pick a distance from x. And so I go over here, and so this would represent x plus h. So that means this distance here is h. I've gone h units away. This would represent my change in x, right? I went h distance from my original starting point. And so that would put me up here at my new point. I graph my line between my 2 points. And so this point would represent x, excuse me, x plus h, and f of x plus h. All right, that slope of that line is equal to the difference quotient, right? My change in x over my change in y. Well, my change in y would be, this would be my first y value, this would be my second y value. And so that slope is still the rate of change, f of x plus h minus f of x all over h, because h is the change in x. Alright, so it is still my slope. It is still my average rate of change from x to x plus h. Right? Average rate of change, so m, which is the slope, is the average rate of change from any x to any x plus h, where h represents the change in x. So it allows us to manipulate it in more cases. Alright, so that's the difference quotient. So we're going to look at an example of finding an average rate of change in an application type. Alright, we'll do that in the next video.